the equation for potential energy, electrical potential energy that is of course K Q1 Q2 over R. Now on a side note, where did that come from? Is it on your formula sheet? Didn't notice. Okay. How's it, Otis? Yeah, it looks very much like gravitational potential energy, right? Let's look at this. What is the force equation, Otis? Oh, sorry, not mass times acceleration. The force of an electric field. What's the difference between those two? Do you see the difference? This is an R and this is an R squared. Yes? How do you connect force to potential energy? Good, good. It's work, right? Potential energy is the potential of a force to do a work. So for example, potential energy is just like force times distance, yes? Now, what if that distance is R? Then that means FR. And when I multiply K, Q1, Q2 over R squared times R, that R cancels, that's how I get this. Sorry, wrong one. That's how I get this. That's where that comes from. Okay. So yeah, it's just a matter of doing this equation twice. And do they give us charges? Oh, 2 electrons. Okay. So we know since they're both electrons, you know their charge is going to cancel. So it's going to be like K Q squared times 1 over D2 minus 1 over D1. Right, did you see what I did there? I just extracted that thing because it's final. This is final D2 minus initial, and so then you get whatever you got there. So this is 9 times 10 to the 9th. This is 1.6 times 10 to the minus 19 squared. So 1.6 squared is like 1.96. So that's 1.96 times 10 to the minus 38. So this is 1.96, I think, right? No, it's 2.16. I always screw up the square between 13 and 16 for some reason. I don't know why. What's that? 2.56? Okay. So 16 squared is 256? Yeah. Okay. So this is going to be 2.56 times 10 to the minus 38. And then over here, we have 1 over 2 times 10 to the minus 10 minus 1 over 3 times 10 to the minus 10. So then, of course, this one, 1 over 2 times 10 to the minus 10 is basically 0.5 times 10 to the 9th. Or this becomes 5 times 10 to the 9th. And then the other one, 1/3 becomes 3.3 times 10 to the 9th. Is that making sense? So I don't know, plug it in your calculator. I'm just doing it all in my head, but what do you get? I'm killing time while you do this. So 9th, so then when you subtract these two, you get 1.7, and then that's to the 9th, so 1.7 times 9 is around 15, like 15 times 10 to the 9th, go times that. Still get a really tiny number. What's the answer? 3.84 times 10 to the what?
19. Negative 19.
Oh, negative 19. Okay, that makes more sense. Negative 19. when we squared the Q, yeah, check it. On your calculators, do it now, all of you. I don't see people calculating. Because I'm estimating to the 9th, 18, no, actually that might be right. Because this is to the 9th, we multiply it times this to the 9th, that's 18. So I think something close. So it's 9 times 10 to the 9th times 1.6 times 10 to the minus 19 squared times 1 over 3 times 10 to the minus, 1 over 2 times 10 to the minus 10 minus 1 over 3 times 10 to the minus 10. And what do you get? What do you get, Eric? Oh, you got this? Cool. We have corroboration. Everybody get that answer? Sweet. Yeah, it looks like it isn't going to work because that 38, but then because we have a 9 over here and a 9 over here in the exponents, it all works. All right, and then the potential gravity. Same smell, right? It's like the same thing. We just have to replace the different numbers. So I'm just going to go ahead and, well, I'll write the formula once. That's big G m squared, and then same thing, 1 over d2 minus 1 over d1. Okay, so on your calculator, you can actually just, if you did this all in one shot, you can do shift enter, it'll pop the equation up again, and then just replace the numbers. So instead of 9 times 10 to the 9th, we're going to use 6.67 times 10 to the minus 11. And then, oh, I never remember this. I think it's 9.31 times 10 to the minus 31. Is it the mass of an electron? It's on the inside of your book. 9.31 or is it 9.11? Is it 911? Is this an emergency? Do we need to check? It's early. You don't talk, I don't tell good jokes. I know it's minus 31 though. And then it's that same part in here. 1 over 2 times 10 to the minus 10. And 1 over 3 times 10 to the minus 10. Okay, what do you get there? And this is squared, remember? Sorry. So this is going to be a massively smaller number. Because this is, we already said like 1.7.
9.11 times 10 to the negative 30.
Okay, that makes sense. This is 9.7 times, 1.7 times 10 to the 9. When I multiply by this, I'm going to get some number to the minus whatever, so. Wait, to the what? Minus 31? Okay, did you get that? Sorry, say that again?
9.11 times 10 to the negative 31. No, for the mass of...
Oh, it's 9.11. Oh, okay, I'm like, hey, that looks just like the other. All right, so my mass number, it is emergency. How can I not remember that? So it's emergency, 911. This should be really tiny. Basically, the answer should be like to the minus 64. Something close to the minus 64, minus 63. Anybody get an answer? Bark it out, bark it out.
9.64 times 10 to the negative 62.
Okay, and what do we discover about gravitational potential energy and electrical potential energy?
Already there.
What's that?
I said that gravitation was a lot less.
Yeah, it's fantastically less. I mean, we're talking about, what is it, 50 orders of magnitude less? So it's much less. And that's good, right? Because this is based on matter. This is based on charge. You can have more than one charge in one place, but you can't have more than one piece of matter in one place. And since planets and crap in the universe is big, that's why this is small. All right. So we got that.